Hi and welcome back. So today's class is going to be done totally on the whiteboard because all of our examples are word problems and the actual writing out of the problem takes almost longer than sometimes what the problem does to actually calculate. So we're going to be talking today about applications of vectors, and we're going to look at a couple of examples of maybe some problems that you might see in some of your future classes. So if you're not really sure about understanding all the parts of the application, that's okay. What I want you to focus on is the trigonometry portion of the application. So in part one of today's videos, we're going to be talking about two examples that involve physics and the idea of force. So in this first example, we have a child, and that child is pulling a wagon at a constant speed with a force of 100 newtons. She is pulling in the direction of the handle, which is making an angle of 25 degrees with the horizontal. And our question is, how much of our force is applied horizontally? Okay, so I have a cartoon up there, but I'm going to go ahead and draw a separate picture here of this wagon. So here is our wagon, and this wagon has wheels, and this wagon has a handle, and that handle is creating an angle of 25 degrees with the horizontal. Alright, now the idea is that the wagon is being pulled, and so the force is being exerted on the wagon, and we can draw that force with a vector that is pointing in the direction of the handle of the wagon. Okay. So when I draw this vector, the force itself is a vector because it has a length, which is the amount of force or the magnitude of the force, and it has a direction, in this case 25 degrees above the horizontal. Okay. Now, a lot of times in physics, it's important to break up the force that we're looking at because we care about the amount of force that's in a horizontal direction and the amount of force in a vertical direction. So some things that I can kind of think about here are, I have this force vector and I can create a right triangle with it, and the portion in the horizontal direction, we can think of that as the x component of our force, and the portion in the y direction we think of as the y component of our force. And if I were to draw this with the vectors, I could break up the force vector into a vertical vector and a horizontal vector. And as far as the physics of this goes, the amount of force that is actually helping the wagon to move forward is just the amount of force that's in the horizontal component of this force vector. If you ever tried to push a wagon directly downward, sort of perpendicular to horizontal, if you push down vertically, the wagon's not going to move forward or backwards. It's not going to move anywhere, in fact. The only way you're going to get the wagon to move is by pushing it or pulling it horizontally. So we only care about the horizontal component of our vector. Alright, so again, I can write down my force vector as the x component and the y component, and what we are looking for is we are looking to find a value for fx, the x component of our vector. Okay, so looking at this picture, some things that I see are that I'm going to take that diagram and I'm going to make it a little bit bigger so I can, have some actual numbers listed in here. So here is our force vector, and then we have our x component and our y component, and we are interested in the x component, and our angle is 25 degrees. And the length of our force vector, whatever that length is, that is our magnitude of the force. And we are told that This child is pulling the wagon, and the amount of force that she is using is 100 N, which is 100 newtons. So the magnitude of our force vector is 100 newtons. And that means that the length of our hypotenuse on this triangle is 100. Okay, so again, we want to figure out the portion or the component of our force vector that's in the x direction. And as far as this triangle goes, this right triangle that I have, Fx is the adjacent side, and the magnitude of our force vector is the hypotenuse side. So it looks like I can think about this in terms of cosine. So we have cosine of 25 degrees is equal to our adjacent side, which is Fx, over our hypotenuse side, which is 100 newtons. And a newton is a measurement of force. Pound is also a measurement of force, but that's in the English system. Newton is a measurement of force in the metric system. Okay, so we want to solve for Fx, so I can multiply both sides by 100 newtons, so I have 100 newtons times cosine of 25 degrees, and that is my value for Fx. 25 degrees is definitely not one of our special angles, so I would want to type this value into my calculator, and I'd better make sure that my calculator is in degree mode, and if it is, you should check that you get 90.6 newtons. And so what this tells us is that that child is pulling on the handle with 100 newtons, but of that 100 newtons, 90.6 of those newtons are being used to pull the wagon forward. So our conclusion is that 90.6 newtons of the force applied by the child is moving the wagon forward. So you might, if you happen to have a red wagon and you have some space in your backyard, you might go out back and experiment with this a little bit and think about sort of the angle of the handle. The closer to horizontal that handle is, the more of the force is being applied to moving the wagon. The more vertical the handle is, the less of that force is being applied to actually move the wagon. Okay, let's look at a second example here that involves force and the components of force. So a person pushes a shopping cart at a constant velocity. He exerts a force of 55 newtons in a direction 29 degrees below horizontal. How much of the force is used to move the cart forward? Okay, so we have this shopping cart here, and this person is pushing the shopping cart, and so here is a vector that is representing that pushing motion, that force, and that force is pushing on the handle of the cart, which should be making the cart move forward. Okay, now some information that we're given is that this person exerts a force of 55 newtons, so that means that the magnitude of our force vector is 55, or 55 newtons in this case. And we are also told that the direction of this force is 29 degrees below horizontal. So if you kind of think of making a horizontal line from the tail of the vector, and 29 degrees below horizontal would be, well, maybe one way to think about that is sort of like our angle of depression that we talked about before. Okay, so we have our force, and we have a 29 degree angle of depression. And our question is, how much of the force is used to move the cart forward? So what we're thinking about here is we have a horizontal component and a vertical component for our force vector. So we have our Fx and our Fy. And we want to know about the portion of the force that is going to be moving the cart forward, meaning the horizontal direction. So what we care about is the horizontal component of our force vector. So we would like to find F subscript x. Alright, now again my little triangle up there is kind of small, so I'm going to make this guy a little bit bigger. And I still have my right triangle. And so the magnitude of our force is 55, and so that is the length of the hypotenuse of our triangle. It's the length of our vector. And we are trying, oh, and our angle here is 29 degrees. And we are looking for the length of the adjacent side. And so it looks like we're going to be using the cosine function again. So I know that cosine of 29 degrees will be adjacent, which is Fx, over our hypotenuse, whose length is 55. So I can multiply both sides by 55, and so I have 55 newtons times cosine of 29 degrees equals Fx. And if I crunch those numbers in my calculator, what I come up with, and you should double check this, is that Fx is equal to 48.1 newtons. And so what that tells us is that of the 55 newtons of force applied to the cart handle, 48.1 of those newtons are used to move the cart forward. So for those of you that are going to go on and take physics, you will spend quite a bit of time taking vectors. Force vectors will be one of those examples. Taking those force vectors and breaking them down into components. So you will have force vectors pointing in all kinds of different directions, maybe up and to the right, and you are going to be asked to break that down into a vertical component and a horizontal component. And the way that you'll think about that is you'll think about the trigonometry of what's going on. Typically your x component will be your adjacent side and your y component will be your opposite side. That won't always be the case because sometimes you'll be looking at the other angle in the triangle and then your adjacent and opposite are a little bit different. But in general, or generally I should say, when you are thinking about finding the components of a force vector, you're thinking about using the cosine function for the x component and the sine function for the y component. Okay, in the next part we're going to be talking about displacement and traveling around by using vectors.